Assalamu alaikum, this is Muhammad Yasir Arafat, and in this video we are going to discuss kinematics for grade 9 as per AKUEB syllabus. To discuss the scalars and vectors, addition of vectors, and resolution of vectors. So before moving into the video, we need to see what are the syllabus learning outcome for students that is provided by the Aga Khan Examination Board. So in the first part of this video, we are going to discuss scalars and vectors. So we all know that the physical quantities usually are defined by using magnitude and unit, but sometimes it requires directions to express. So with the help of these three entities, we would be able to define any kind of physical quantities. We are having few examples of some physical quantities that usually requires direction, and some of them do not require direction. Just like first example, it suggests us that the 5 kg of sugar. Here 5 and kg both are the magnitude and unit that is represented in this particular example. But there is no hint for any kind of direction. And in the other example, we can see that 15 kilometer towards east. But here in this particular example, we can see there is a magnitude unit along with the direction is given. So when we are having such examples, how we would be able to classify which physical quantities or which type of physical quantities they are related to. For that, we are required to start with the scalars. So for a scalar quantity, we know that we require magnitude and unit here. So with the help of magnitude and unit, we would be able to express a physical quantity that is considered as a scalar quantity. So there are some examples that is given in here. So as we have discussed this example previously, that is representing 5 kg of sugar. So here 5 is the magnitude and kg is the unit. So this magnitude and unit usually represents that this is the physical quantity that is mass. There are some more examples related to the scalars, and those are the distance, speed, energy, and area. So these are the examples that is used as scalar quantities. There are many more examples like time, like pressure, like volume. Those all require magnitude and unit, but direction representing direction is not necessary for them. When we are dealing with the vectors, we must know that along with the magnitude and the unit, we also require the directions. So with the help of these three entities, we would be able to express the physical quantity that is named as vectors. So there are some example that is given. One here, that 15 kilometer towards east. So here 15 kilometer towards east is representing you the here 15 kilometer towards east is representing magnitude, that is 15 kilometer, that is representing you the unit, and towards east that is representing you the direction. So distance with the direction usually named as displacement that we have discussed in the previous video. So this displacement could be considered as the example of a vector. There are a few more examples that are the velocity, acceleration, force, momentum, and torque. These are the many examples that could be placed as vectors. We are moving towards the method to represent a vector. So there are multiple methods to represent a vector, but we will be focusing on the graphical representation of a vector. So whenever we are using a graph, we need to draw an arrow, and the tail of that arrow will be representing as the magnitude, or it will be giving us the size, and then head of the vector will be representing you the direction. Remember, this head could also be considered as the terminal of a vector. Let's move towards the addition of vectors by using head to tail rule method. So for the addition, we are having two vectors, and both of them are drawn from by drawing an axis, and from the origin, it will be drawn here. We can see that at the origin of the vector, there is an axis is drawn. So it will make our life more easier to use a vector with the help of their direction as well. So there is another vector, and the second vector is having different angles. So that means both the vectors are having different magnitude and different direction. So we would be adding them by using the head to tail rule addition of vectors. So we are going to name them now. These are the angles that is represented, and remember the angle of any vector that is going to be drawn, that should be creating an angle with the x-axis. So first we need to draw an axis with a dotted line. So it will be helping us to use a vector with the correct direction. Now from the origin of this axis, we need to draw the first vector, that is vector A. So as we are going to follow the head to tail method, so again we are going to use the head of the first vector, and we would be drawing the axis. These axes would be drawn as imaginary ones, and then we would be drawing the second vector with the same angle that is created initially in the given question. So when the vector is drawn, we can get the idea that they in which direction they have connected here. So if you follow this figure, it shows that the vectors are connected in anti-clockwise direction. So when the vectors are connected in anti-clockwise direction, remember you need to draw the resultant vector, and the direction of the resultant vector should be drawn like this by following clockwise direction. So now what we will be doing, we would be using the origin of the first vector, and from there we would be connecting the arrow, or connecting by using arrow the head of the second vector. So after drawing them, we will be naming the vector A and B, and the vector R is showing you the resultant vector. So just remember that the size of the resultant vector will be giving you the size of the entire result of the vector that is added here. Remember, their order, the change of the order will not be affecting them on the magnitude of the resultant vector. So there are few points that should be remembered. So the angle should be remain same whenever you are drawing the first vector and the second vector. So without changing the angle, remember there are if we change the order, it will not going to affect the size of the resultant vector at any case. But remember, the direction of the resultant vector could be changed by that case. So points to be noted here. When individual vectors are connected in anticlockwise rotation, then draw the resultant vector by using clockwise rotation. So in the new diagram, what we are going to do here, we are going to change the order of the vector by keeping their angle same. Do not change the direction whenever you are changing the order. So what we are going to do, we are going to follow the same method. We would be drawing the vector b first here, and after drawing the vector b, then we would be doing the same thing with the head of the vector b. We would be doing the drawing the virtual axis. So that virtual axis would be drawn by using dotted lines. Now here you can see that the vectors are connected in which direction? They are connected in clockwise direction now, isn't it? So when the vectors are connected in clockwise direction, so what should be done here? The resultant vector should be drawn in anti-clockwise direction. And for that, what we need to do, we need to use the origin of the first vector and the head of the last vector. So we need to connect them with the help of an arrow, and the direction of the arrow should be in anti-clockwise direction. So you can label them at the end, and the angle should be remain same whenever you are using the addition of vector, and whenever you are changing the order of the vector. So when individual vectors are connected in clockwise rotation, it is necessary to draw the resultant vector by following the anti-clockwise rotation. And the size of the resultant vector will be equal to the measured length of this vector, and the size of the resultant vector should be less than the sum of the individual vectors. But the resultant vector should be more than the size of the individual vector. Okay, so if it reflects you that if we are having the vector A of size 3 meter and vector B has a size of 4 meter. So when we are adding them, it will be providing us 7 meter. So that means the size of the resultant vector should be smaller than 7 in that case. But the magnitude of the resultant vector should be more than the size of the individual vector. Means that it should be more than the 3 meter as well as 4 meter. Okay, so by following this method, we would be able to show up a resultant vector by using graphical method. So let's move to the last topic in this video, and that is resolution of vector. So whenever we are dealing with the resolution of vector, just remember that resolution is a method in which we are going to split a vector into two or more than two parts. Doing that, use a graph, draw the axis, y and x-axis, and then draw a vector. We all know that the vector is drawn here. Now what is required to be done? You need to name them. Just like we are naming this vector as vector A. So after drawing the vector A, what is required to be done? You need to draw uh, a parallel line to the x-axis by using the origin of this vector. That would be named as AX. And a parallel line to the y-axis by using the head of the vector or the terminal of the vector. That would be named as AY. And you can see this vector A is creating an angle with x-axis, and that is about to be considered as theta. And on the other side, it is creating 90-degree when the vector AY and AX are intersecting with each other. So it reflects you that the triangle will be formed here is a right angle triangle. So whenever we are dealing with the right angle triangle, what is required to be done here? We are going to use the trigonometric ratios. So whenever we are going to use the trigonometric ratios, we would be able to find out the magnitude for each component of a vector. So these are the trigonometric ratios that is required to be used here. Sin theta equals perpendicular upon hypotenuse, cos theta equals base upon hypotenuse, and tan theta equals perpendicular upon hypotenuse. And at the end, we would be using Pythagoras theorem when is required. So First, we are going to find out the horizontal component. Remember, whenever you are dealing with the horizontal component, you need to ignore the vertical component. So here you can see that AY is not present here. AY is missing here in this diagram. So that means we need to ignore that vertical component here. So what we will be doing, we would be using the AX and the hypotenuse. So we would be using the base and hypotenuse. So by using this base and hypotenuse, we would be able to get the for equation for calculating the magnitude of vector AX. So for that, what we are required to do, we are required to use cos theta equals base upon hypotenuse. As base and hypotenuse both is present in the cosine function, so now we are required to replace base with ax and hypotenuse with a. Then shift a towards the left hand side because the denominator is going to move on the left hand side and it will be multiplied by cos theta. So at the end it will be look like as a cos theta equals ax. So we can rewrite them as ax equals a cos theta. This is the main equation whenever we are dealing with the horizontal component. If we are required to get the magnitude for the x component for a vector, if the angle is given, so we would be able to find out by using this formula. If we are required to deal with the vertical component of a vector. So whenever we are dealing with the vertical component of a vector, we are required to eliminate or ignore the x component here. So what we will be doing, we will be using ay and vector a. So we will be ignoring the ax here. So in this particular section, we would be using the vertical component ay, and that is perpendicular here, and vector a, that is hypotenuse. So we would be using sine function. Remember, this is the sine function that is representing you the perpendicular upon hypotenuse. So we will be replacing perpendicular with ay and hypotenuse with a. So a, the denominator would be shifted towards the left hand side. That will become a sine theta equals ay. And then we would be rewriting the entire equation as ay equals a sine theta. So with the help of this equation, we would be able to get the result or the magnitude for the y component of the given vector. So now we have got the equation for the vertical component, that is ax, and we have got the vertical component for ay. Okay. Now we are required to find out the magnitude for the resultant vector. So whenever we are required to find the magnitude of a resultant vector, we are required to use all the components that is present in the triangle. So vector ax, ay, and vector a would be used here. And we will be applying the Pythagoras theorem that suggests as hypotenuse square equals perpendicular square plus base square. So in the place of perpendicular square and base square, what we are going to do, we are going to use ax instead of perpendicular, ay instead of base, and a instead of a hypotenuse. So after placing them, we need to take the square root on both sides so that we can get the magnitude, we can get the equation for the magnitude of a resultant vector, and that is a. For this entire diagram, vector A is your resultant vector. So what is required to be done is square root needs to be cancelled with the square. Remember, on the right hand side, you can see that there is an algebraic expression, and that expression is presented with the plus sign and negative sign in between the ax and ay. So whenever we see plus or negative sign between the ax and ay, or between the two variable, we won't be able to cancel out their square root with their squares. Okay, so on the right hand side, the things are not be changing. They will be remain same as its place. So in the next step, what we will be doing, we will be getting a equals the square root of ax square plus ay square. Now we are required to get the direction of a resultant vector. So whenever we are getting the direction of a resultant vector, what is required to be done? We are required to use the tan theta equals perpendicular upon base. As we all know that the tan theta equals perpendicular upon base. So perpendicular is your ay and base is your ax. So what is required to be done? You need to shift 10 on the opposite side. So when the function is changing its side or it is shifting towards the other side, it will become inverse now. So and so what will happen? It will be represented tan inverse equals ay upon ax. Remember, this is the angle that is represented by arrow that would be measured if the angle is not given. So with the help of ay upon ax, we would be able to get the angle if we take the inverse or tan inverse. If such thing happens, when ay is equal to the ax, we would be able to get the inverse of ay upon ax as tan inverse of ay upon ax would be equal to 45 degree if the magnitude of ay and ax is same. So that's all from my side. Thank you for watching.